Hello and welcome to this new video. Following the completion of the previous video where we talked about the utilization of ILA and VIO to debug your design in Vivado, in this video we are going to talk about triggering. And triggering essentially helps you to be able to capture your signal and be able to observe what happened on a specific window size after the trigger, before and after the trigger happens. So you'd always want to observe what happens with this particular window. It allows you to capture the signal and the behavior of your circuit within this particular window. So to do that, we're actually going to utilize our reset on this particular circuit, where we're going to have it actually on the FPGA itself. So the first thing we want to do is to create our pin, our reset signal, so that, and we need to add that on our IP integrator here. And let's see, we search for, so the processor, we need to utilize this processor's system reset, because we would like to, we would like to have a synchronized we would like to synchronize our reset signal to the system clock domain. This is especially when because we are working in a block design that involved IP blocks that expect synchronous reset. So to do this, so this is how we connect. You connect the, and then this particular reset, we will connect it to the external reset, and then we take the peripheral reset and connect it to the reset of our module now. So we validate it and it validates. We go to our design. We should be able to validate again, and then we, okay, well, it's still not showing, so we need to regenerate our VHDL wrapper once again, and then let's check now. Yeah, so it has now added. Now we can go to running synthesis, and then after synthesis is complete, after synthesis is complete, we open our design so that we'll be able to assign the reset pin to a particular switch. In this case, the ZCU104, we're going to use switch 0, which is going to be E4. So we go to our IO planning, and then we select E4, E4, and our VCC is going to be LVCMOS 33. We save it, and then now we run our implementation. So now that our implementation is done, we go to generate our bit stream, or you can just go directly from synthesis to generate bit stream. So bit stream is done. So now we program a device. Okay, so now this window opens. We should be able to see our reset signal here. Here we can see the outputs to our module. We set them, and these are the inputs, and we're able to play around with this. As you remember, these are the AB and carry in of our adder, for our full adder. However, it seems that I don't see the reset signal. Let's see. Okay, we did not connect it to our probe for the VIO. Okay, let's validate it again. Okay, so we are now implementation. Generate bit stream. Okay, so let's try this again. Okay, so I need to reconnect again my device, my FPGA. Open target, and then okay, now program device. Right, so let's see if we can find it now. Well, it seems like it's still not there, so what could be the problem? I'm still not able to observe our reset signal. Okay, so I believe that the problem could be, let's see. Okay, so if you go to synthesis and then you set up debug, it brings you to this particular window, and here we'll be able to search for our reset signal and see if we actually have it on as and see what actually is happening to it. So we come here to add net, and then we select our reset. We search for reset. Okay, and you can see it here. And okay, and then we should add it. Okay, I see. So every signal should be associated with a clock domain that tells the ILA and we have to tell the ILA which clock to use to capture the signal. As you can see here, our reset is not associated to any clock domain. It's undefined. So this is actually the problem. So what we need to do here is we go to more info and then assign all clock. Okay, we cannot see a clock here. Let's see all the clocks, and let's see which is our clock. So we will select let's select this one, top level clock, and then okay. So for the rest of this should be fine. This simply tells you the sampling, the amount of sampling data that we should do. So we come here and then we reload our design. So let's go directly to generate bit stream. Now let's open our hardware manager and let's see, load our new design. Let's see. Okay, so let's see if we'll be able to add it here. Okay, now you can see that we have our reset right there. Okay, let's delete the old reset, and now we add our new reset as our trigger. You add it there, and then you select the rise, trigger on the rise, and then here essentially you would want to get the current status of your signals. And then to arm the trigger, we click the play button, and now you can see that it's armed, and then we trigger it and it gets triggered. So you're able to observe the signal, your waveform, the behavior of your design right before and after the trigger. Now let's see this again. Set the trigger, then we click on our trigger. You see it's waiting for trigger, and now it has been triggered after I reset the signal. So that's how you set your trigger, and thank you very much for watching.